Welcome everyone. This is week 4 discussion and we will be covering sets this time. Let's start. Um, a set is a collection of distinct objects. This is how it is usually represented as that element x where x belongs to A. So you write all the elements in the set A. So for example, if the set A is, is supposed to have elements 1, 2, 3, and 4, so then this set would be 1, comma 2, comma 3, comma 4. That is, you write the elements x that belong to the set A, right? Alright, so the members of the set are the elements of the set, right? And Z is defined as a set of integers, N as the set of real numbers, Q as the set of rational numbers, and this is called phi, pronounced as phi, which is the empty set. And just a revision of cardinality of a set, that is the number of elements in the set A that is written as the magnitude of A or n of A, that's the cardinality of A, right? Just remember this part, that the cardinality of a set. Next, what a subset? So subset is a set of collection of elements drawn from the original set. It is written as A is a subset of B. So if you're given a set A is equal to 1, 2, 3, and 4, which of the following are subsets of A? So 1, comma 2. Again, let's define the subset. So it's a set of collection of elements drawn from the original set. So is 1 comma 2 drawn from the original set A? Yes, because 1 comma 2 exist in the set. Phi, that is an empty set. So an important characteristic of phi is that an empty set is a subset of all sets, right? 4. So is 4 drawn from the original set? Yes. We have 1, 2, 5. So because we have this number 5, that is not a part of the original set. So it's not it's not a subset. 1, 2, 3, and 4, yes, it is a subset. So a set is a subset of itself. You can say that. Let's write it down as well. Set is a subset of itself. Like every set is a subset of itself, right? So think about this. If you have 4 elements, what are the number of subsets possible? Think about this. We will be answering that question in the next few slides. But if you're given 4 elements, how many subsets can this set have, right? Alright, as we looked at it, 1 to 5 is not a subset. A proper set A is a proper subset of B if the subset is not equal to the original set. Then it's called a proper subset, right? A universal set is a set that contains all the elements in the universe. So yeah, we're looking at the number of subsets possible for a set A, that is 2 of cardinality of A. The intuition is that for every element in a set, you have 2 choices, that either you place it or no. Let's look at an example. You have 1 and 2, right? So you have 2 choices to put 1 in, that is you put it or you don't. For the element 2, you have 2 choices again, that you put it or not, right? So let's start with not putting either one of them. So you have an empty set. Then you choose to put in one of the both of them. So that's 1. Or if you choose to put 2 in them, and then for 1 and to both of them you choose yes, right? So you have 4 choices. Let me just write the choices that you took. Okay, this was 0, 0, 1, 0, or let's just do it true, false, false, true, false, and false, true, and true, true. So you chose to put, you did not choose 1, you did not choose 2, you had an empty set. You chose to put in 1, you got 1 here, but you did not choose to put in 2. And here you chose to put in 2 and not 1, and here you chose to put in both of them, right? So you have 4 choices. So that's for every element you made two choices, and hence it's of the form 2 times 2. But now if you have n elements in the set, it just goes on because you have two choices to make each time for every element, right? Where the set is, right? So that is what is called a power set. A power set is a set of all the subsets possible for a particular set, right? And the number of elements in a power set is equal to the number of subsets possible. That is 2 raised to the cardinality of the set A, right? Okay, so let's look at the three sets here, A, B, C. We'll try to find the power sets of each one of them. Alright, so you have A, B, C, D, and E. You start with an empty set, that is phi. Then you'll go on to choosing individual elements, that is A, B, C, D, and E. Then two of them, then three of them, and then so let's just, you can choose none of them, then you can choose one of them, two of them, three of them, four of them, and then five at the end, five of them. Okay, so let's just look at the elements written down. So here you have none of them, then here it is all one of them. Let me just color them up for you. So these are one of them, all of these are two of them again, then the three of them, four of them, and five of them. So here you see that you start with making choices that should I put A, B, C, D, or E. None of them would be just one set. One of them, so that I can put in one A, B, C, D, or E, any one of them. Then here you put in any two of them, right? So these are just combinations that you kind of make, right? So here, looking back at the formula, the size of the power set would be 2 raised to 5. 1, 2, 3, 4, 5. So you have 32 sets possible. Even if you have individual sets, individual elements, make sure you put in these braces, right? Curly brackets. Alright, try to find out the power set of B and C and let me know if you have any questions on those, right? Okay. Next is trying to understand different set operations. You're given three sets A, B, and C. A is 1, 2, 3, 4. B is 3, 1, 5, 6. The order never matters, just remember that. C is 5, 6, 7, and 8. The first operation that we'll be looking at is the union. So the union is a set of elements which are in either of the sets. So just make sure if you're given A union B, you want to put in all the elements that are possible in A and B, right? So it's going to be 1, 2, 3, 4. Look at B. 3 is already entered in A, so it's already there. 1 is already there. 5 and 6 are new, so you put in 5 and 6, right? So you want all the elements that are possible in both of them, either one of them, or either of them. So let's say both in A and B, and only in A and only in B, right? B union C would be, let's look at here, all 1, 2, 3, 4. That's, sorry, B, C is here, so that's 3, 1, 5, 6, and 5, 6, 7, 8. So we have 1, 3, 5, 6, 5, 6, 7, and 8, right? So that's the union. That's elements in either one of them, not either one, either of them. So there's a big difference here actually. It is either of them. And not either one of them. Okay, that is a symmetric difference. And that's written as A XOR B. And that would be all the elements that are only in A and or only in B. Okay, so if I had to say what is the symmetric difference of A XOR A B, it would be something like, so look at A and B, right? What are the common elements? 1 is there in both of them, 3 is there in both of them, right? So it will just be 2, 4, and 5 and 6. All right. So that's the symmetric difference of A, and it's, I'll just put in the symbol for that as well. Oops, I'm sorry. Just here. That's not the symbol I'm looking for. Right there. Circle plus. Okay. Right. So that's how you write a symmetric difference. A is or B. Okay. Yep. So that's a union and symmetric difference. Let's look at intersection. So intersection is in both the sets. Elements in both the sets, that is the common elements of A and B, right? So A and C do not have any common element, and that's why it's 5. All the common elements of B and C are 5 and 6. Alright, so the intersection between B and C is 5 comma 6. The difference is all the elements which are only in the first set and not the second set. That is, A minus B would be, take out all the elements that are common between A and B from A, right? The common elements between A and B are 1, 3. So you take out 1, 3 from A, that's 2 comma 4. And then A minus C would be, take out all the common elements from A that are common between A and C. The common elements between A and C are is 5. There are no common elements, so you cannot take out, you don't take out any of the elements, and it just stays as 1, 2, 3, 4. Universal set is set of all elements that exist in the universe, so you just union all of them. That's why you have 1, 2, 3, 4, 5, 6, 7, and 8. A complement is all the elements that do not exist in the set. So you basically do, what you do is, it's just the universal set minus the set A. Okay, so you remove all the elements from the universal set that exist in the set A. And similarly with B, where you had 3, 1, 5, 6, and the universal set had 1 to 8 elements. So you remove all the elements that are in B from the universal set, and you have U minus B. So that's the whole thing. The Cartesian product is another form of a set which has all the elements of the form A comma B, where A belongs to A and B belongs to B. So you write all the elements, all the combinations possible as A comma B. So if you have given the two sets A and B and you need to write the Cartesian product, that is 1, 2, 3, 4 and ABC, you map 1 with A, 1 with B, 1 with C, 2 with A, 2 with B, 2 with C. So for all elements of A and B, you write the pairs possible in the form of A comma B. So you have 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B, 3C, 4A, 4B, 4C. Right? That's the Cartesian products possible. And the size of the Cartesian product is always written as, because that's the product, right? Because you making combinations from the two sets. So there are like n A elements in the first set and n B elements in the second set. So the number of elements in the Cartesian product would be Na times Nb. Right? Let's do a few exercises over this now. So you're given the universal set already as 1 to 9. Set A has 1 to 5, 1, 2, 3, 4, 5. B has the elements 4, 5, 6, 7. C has 5, 6, 7, 8, 9. D has 1, 3, 5, 7, 9. E has 2, 4, 6, 8. And F has 1, 5, 9. First question is to find out the union of A and B. The second question is to find out the union of A and C. And the third question is to find D and F, the union of D and F. Let's start with A and B. So A has the elements 1 to 5 and B has 4, 5, 6, 7. So the union would be 1, 2, 3, 4, 5. And then here you have two elements missing, that's 6 and 7. A union C would be 1, 2, 3, 4, 5, and then 5, 6, 7, 8, 9. So 1 to 9 elements. B union F would be 1, 3, 5, 7, 9. And when you look at set F, both the elements are already there in the set. So you don't need to add anything to the set D to find the union of D and F. Alright, next question is to find the intersections of A and B. What are the common elements between A and B? So that's going to be 4 and 5, right? What are the common elements between A and C now? So that's going to be 5 alone. What are the common elements between D and F? So that's 1, 5, and 9, right? Okay. All right. Next is the complement. So the complement is all this common elements between the universal set and the element A. The set A are removed from the universal set. So that's like subtracting A from U, right? So that's from 1 to 9, you just remove 1, 2, 3, 4, and 5. So it is 6, 7, 8, and 9, right? And then from set B, you remove 4, 5, 6, 7 from the universal set. So it's going to be 1, 2, 3, 8, and 9. And complement of C would be removing 5, 6, 7, 8, 9 from the universal set. And that will leave you with 1, 2, 3, and 1, 2, 3, 4. Okay, here's another question. Let's try to find out the A intersection D union F. So for this, you need to find out D union F first, and then find the common elements between A and the set D union F. So D union F is 1, 3, 5, 7, 9, and then you find the common elements between A, that is 1, 2, 3, 4, 5, and 1, 3, 5, 7, 9, which leaves you with 1, 3, 5. That's how you find intersection of two sets where one of them is already another operation, that is a union, right? Okay, next question is finding one, you're given three sets, 1, 2, x, y, z, and 3, 4. You need to find the Cartesian product between A and B, and then A cross B cross C, right? So as I said, a Cartesian product is defined as um, all the elements of the form A comma B where A belongs to the first set and B belongs to the second set, right? I'll just write that definition down again. A comma B where A belongs to B, A and B belongs to B. Alright, so let's find the answers for the first one. A cross B would be 1x, 1y, 1z, 2x, 2y, 2z, right? How do we find A cross B cross C? That's going to be tedious. So let's just be, that A cross B is written as 1x, 1y, 1z. That's what we got right here. A cross B cross C is just A cross B cross C. We already know this answer, and then we just need to cross that with the elements of C, that is 3, 4, and that's how you'll end up with the answer right here. Make sure you put in the curly braces when you write sets. A question would be, is our Cartesian product commutative? Think over this and discuss with me in case. Next question is a pretty easy question. You're given a element that is 2x, x plus y, which is equal to 6, 2, and you're supposed to find the values of x and y. Right, so it's pretty easy because the elements of a set which is supposed to be equal. So 2x is 6, x plus y is 2. So you just put in the values here, like x is 3, and you place the value of x in the second equation. So this is the first equation, and this is the second equation, right? So from 1, x equal to 3 is placed in 2, where you find that y is equal to -1, and hence x equal to 3 and y equal to -1. Pretty easy, right? Good. Okay, next question is finding the power set of the given sets. You're given 3, 4, and 7 as the first set. and 3, 4, 7 union 3, 4, 5, 6 as the second set, and you need to find the power set. Power sets are written as P, oh sorry, as P of the set A. So that's the power set of A. Okay. And if you given P of A, that's the power set of the power set of A. Okay. I'll just write this down because I'm putting the slides up. All right, the power set of 3, 4, 7. So that's going to be none of them, one of each, two of each, and then all three of them, right? As you were discussing for the how to find the power sets. Make sure you keep the braces in there. And similarly for 3, 4, 7 union 3, 4, 5, 6. Let's first find the union of 3, 4, 7 and 3, 4, 5, 6. That's 3, 4, 5, 6, 7. And then the Cartesian product accordingly, that is none of them, one of each, two of them, three of them, and four of them, and then finally five of them, right? Okay, an interesting question on here is that there are 100 students enrolled in one class. 60 of them are in chemistry, 45 in physics, 30 in biology, and some of them are in both, and then there are 10 in all three of them. We need to find out how many are exactly enrolled in two classes. That is not enrolled in all of them or in one or none, but exactly two classes, right? So we first start with depicting the Venn diagram, that is chemistry, physics, and biology, right? And we know that there are 10 in all three of them, so this region is all of them. This is the region which has chemistry and physics, chemistry and biology, physics and biology. This is only chemistry, only physics, and only biology, okay? Now we know that, let's just first put in x, y, z for them that are for exactly enrolled in two classes. So I need to find out x plus y plus z at the end of the day, because I want to find out that how many are exactly enrolled in two classes. That's x, y, and z. Right now I know that there are 45 in physics, so the only physics part would be 45 minus x minus z minus 10, right? Similarly for chemistry and biology, you can find the answer, that is 60 in chemistry minus in chemistry and physics, chemistry and biology, and in all of them. So 60 minus x minus y minus 10, and 30 minus y minus z minus 10. Now all of them need to be, when I add all of them, they need to be equal to 100 because there are total 100 students. So I add all of them up, that is 60 minus x minus y minus 10, 45 minus x minus z minus 10, 30 minus y minus z minus 10, x, y, z, 10. I get the answer as 115 minus x minus y minus z, which should be 100. And hence I have the result, that is x plus y plus z is 115. And so there are 15 students who are exactly enrolled in two classes, right? Okay. So next question is, there are 9 in chemistry and physics, 4 in physics and biology. How many are in chemistry and biology? So we are given chemistry and physics, so that's chemistry, physics, that's x. We're given y for chemistry, sorry, we're given z, that is physics and biology. And we need to find for chemistry and biology, that is y, right? So we're given x as 9, z as 4, we need to find y. So that's x plus y plus z is 25, from the previous one that we knew. 9 plus 4 plus y is 25, and we have y as 12. So this is 12, this is 9, and this is 4. So number of students in chemistry and biology is 12. Right? Interesting question. Okay, this is the most important question of the day and the last question for now. For any set A, B, and C, any sets A, B, and C, if you're given a statement that is the Cartesian product of A and B is the subset of the Cartesian product of A and C, and you're given that A is not an empty set, then B is a subset of C. So if you're given A cross B is a subset of A cross C, then B cross B is a subset of C. right? So let's start. For now, choose some element x that belongs to B, and since A is not an empty set, we can choose another element T from set A, right? So T comma x belongs to A cross B. Since T is an element from A and x is an element from B, so T comma x belongs to A cross B. That's the definition of Cartesian products. Now, since T comma x belongs to A cross B, and we also know that A cross B is a subset of A cross C, we can say that T cross x will belongs to A cross C, right? So we know that T comma x belongs to A comma C and T comma x belongs to A comma B. Now, but then x would belong to C since T comma x belongs to A comma C, A cross C, right? Did you get it? What happened here? Since T comma x belongs to A cross C and T belongs to A, x will have to belong to the set C. So we started with an element from B and we just ended up proving that every element in B would belong to every element would belong to the set C, right? So if x belongs to CB, then x belongs to C, but not the other way around. So B, all the elements of B would also belong to all the elements of C, and hence B is a subset of C, right? So for these kinds of proofs, always try to choose an element in one of the sets and prove that that element would also belong in the subset, in the superset, right? And that's how you need to prove different proofs. And that's it. Yep. So if you have any questions, please email me. And yeah, that is sets for now. And yeah. Stay safe and have a good week ahead. I'll see you next week. Thank you.